All right. Well, that'll work. Okay, and then I go back to StreamYard. Hello, everyone. Give me just a moment while I am working this out. Welcome, welcome, welcome. Hey, Noel. How you stayed with the changes. That's awesome. Good to see everyone. I need to put the URL for this new copy into the old episode because the old episode is broken, because that's how life works sometimes. Right. I think I have everybody. I have Rafael joining me. This is Maui Lion. I have a few audience members. I have Russell saying hello and Noel saying hello. Right. We have managed to pull it back from the edge, and now we're gonna get started here. So welcome, Rafael.
Hello.
So usually at the start of these things, what I do a little screen sharing. Give me one moment to get that set up. Threw a wrench in my go. Put you there. I'm going to take you out of the podcast for just a minute. Okay. Now, welcome to episode 20 of the eBPF office hours. In this episode, I'm going to explore a pretty interesting project that came up at the eBPF summit. And that project is called Conntracker. It really caught my imagination because it seems to be a tool that will give you some real-time analysis for packets that are moving through IP tables. And if anybody is, if y'all are familiar with IP tables, you know that like trying to understand the life of a packet through IP tables can be rather daunting. There's a lot of rules, and they are not particularly easy to follow if you've been trying to follow what's happening for a particular life of a packet. And so I was super fascinated by this, and I decided to do an episode on that. I also reached out to Rafael, who is the author of the project, and he will be joining us in this episode and answering questions for us and those sorts of things. So I'm super excited. That's what we're going to do for this episode. For the news this week, we have a really awesome announcement, and it's on our Isovalent blog. It is AWS picks Cilium for networking and security on EKS Anywhere. And so for the new announcement of EKS Anywhere, Cilium will be the default CNI in clusters that you create in this way. And this is a pretty interesting project. I've actually had a chance to look into it a little bit. Right now, they're targeting only vSphere as the virtualization platform that you can deploy EKS Anywhere on, but I imagine that'll change pretty quickly And one of the reasons I imagine that, is that it seems that the tooling behind this is Cluster API, a project that I worked on at VMware and also at Heptio. And so Cluster API is tooled specifically to enable the easy adoption of other environments. Cluster API has environments for AWS, Azure, Oracle Cloud, like all of the different, a bunch of different providers for different infrastructure. In fact, I think even there's a bare metal one that was being built by the Equinix Metal folks, but I haven't looked into it recently. One way or the other, though, since it's based on Cluster API, I imagine that it would be somewhat extensible and that you'd be able to do EKS anywhere pretty soon in other places. The last part of this news, which I think will be exciting, is in 2 weeks when I am next on eBPF office hours, I'm going to be hosting Justin Garrison, my good friend Justin Garrison, and he will be answering questions and we'll be playing with it a little bit and kind of exploring that sort of stuff together. So that should be super fun. That's the big news for this week. If you want to check out Conntracker, you can go to the GitHub repository where it is located. Rafael has done a ton of work to make this pretty easy to play with, including hosting including having set up a PPA, which is kind of like it's sort of like a repository where you can like push packages that you're responsible for that sit outside the main packaging system, right? And so in this way, you can actually configure your apt command or what have you inside on Ubuntu to be able to pull particular packages that are available. Maybe they're just like edge packages that are just released or like following nightlies or whatever. There's lots of good reasons to have a repository like this. And in this case, it just really eases the friction of downloading this tooling and getting it turned on for your cluster. And so this was something that Rafael turned on kind of for this cluster or for his package, and also did some other interesting stuff. Like he's actually using BPF to trace information about like what process is making the call and that sort of information. And when you're leveraging BPF, as we've covered any number of times here on this office hours, one of the big challenges is like you need to be able to you need to have that BTF, that type format information about from the kernel, so that you can actually trace it back to process names and things like that. And so a lot of kernels now are actually enabling that kind of by default. And so if you are on, I'll show you that here in a second when we get to the demonstration part of it. But if your kernel actually ships with this, then you'll actually have something under, I think it's sys debug, no, sys, I'll have to think about where it is, but we'll look at it together. But if it is there, then this application will just be able to use it. And if it is not there, then you'll have to provide it in some other way. One of the neat things about this project that I was really impressed with, that Rafael did, was actually work on a project that would enable you to download BTF information that was necessary for his work through a different project. And so if you didn't have BTF information already compiled inside of your kernel and made available as part of the sys file system, then you could actually use this other project to download it for the particular target kernels that he was aiming this application for, which is actually pretty cool. So that is kind of a pretty decent overview of what's in the project. I think it's time to kind of get started with the demonstration here and play with things. Saying hello to Daniel. How you doing? Good to see you, Russell. All right. So let's do some IP tables things and see what we can get, see what kind of trouble we can get into. So what I've done to set this up is I was actually playing with Ansible earlier this week, and I was playing with KubeSpray, which is an open source Kubernetes installer, earlier this week, and I realized that it has a pretty extensive Vagrant configuration. And what this allows me to do is bring up a Kubernetes cluster leveraging Vagrant. And there are lots of knobs and dials for how I want to turn, or what I want to turn on and what I want to turn off and that sort of stuff. And so this is the output of the Ansible run for this particular cluster. And what we've done here is we've created a 3-node cluster. So if I do kubectl get nodes, can see that there are 3 nodes and they're in state not ready, and that's mainly because I haven't installed a CNI. One of the configurations is to have that cluster come up without a CNI. I'm going to go ahead and install Cilium here. And we'll just install the latest version of the open source Cilium package. And then we'll probably use Cilium connectivity test or something like that to generate traffic. And then we'll take a look at the cluster. So while that's installing, let's jump in here and take a look at these nodes. Okay. So cat etsy lsb release. So this is the Ubuntu 2004. It's a focal code name, and that fits into the version that you've built this for, Rafael.
Yeah, and it's using a hardware enablement kernel. It looks like, yeah. Or this one, okay, 5.4.
This is the stock one, 54081. And then sys kernel
BTF, debug
yeah.
BTF.
Oh, sorry, sys kernel BTF. You're right. I don't think the stock one has, perhaps.
Oh yeah, so that's the thing. The 5.4 doesn't have it. That's why we need the external BTF file.
Mm-hmm. Yep. So we'll be using that, and so so yeah, that'll be. So Cilium looks like it's up. We can see things there, and if we do Cilium connectivity tests, we'll just generate a couple of pods and throw traffic between them and validate things like network policy and that sort of stuff. We should be able to see that generating traffic. So if inside of here we do CRI kettle, yes. Oh, okay. Only wired up for root. That's right. I remember this before. There we go. We have Cilium installed. We have containers that are being deployed. We have things that are working. Okay. We're generating traffic. And so the next thing I wanted to do was kind of work through the docs and get this installed. And so I thought I would pick it up at the PPA. And what this will do is it will actually add the repository that is part of the PPA program for Ubuntu. You can see it's hosted underneath ppalaunchpad.net. It's under Conntracker, and then we'll actually be able to pull the packages that are made available in that repository into our local system. So let's go ahead and do that on all 3 nodes. Just make that upper window a little smaller. And we'll add a couple other windows here. So in the output of one of them, oh, okay, clearly, yeah. So this is a 64-bit machine, and it was just basically being telling us that it skipped the binary i386 packages because this particular configuration of Ubuntu doesn't support i386, which totally makes sense. All right. So dig in a little further here. So for the focal release, it looks like what I want is this install command. And it will do an install of Conntracker and the Conntracker BTF and make that available. I'm curious to dig into the BTF piece of things and see what is actually packaged there. That'll be kind of a fun one. So let's go ahead and get these. And get these installed.
You want to see the contents of that?
Yeah. I can't remember what the...
Yeah, dpkg dash capital L, and then Conntracker dash BTF. And then there is an external BTF file.
Yep. And you're putting that inside of that BTF file. That's basically like if you were to build the kernel yourself and hold, and then with the export of BTF of the BTF file types and stuff, right? You just
so
VM Linux or something else.
Yeah, I'm using the PA-HO tool from Dwarf, and then extracting the BTF out of the debug symbols that are available from the official repository and generating those.
Oh, okay. So that might be the entire. So like, I remember when going through this process myself a bit. One of the challenges was that like you could include BTF symbols for the kernel and all of its modules, which is huge.
Yeah, it's like 600 megabytes each debug package. So each compiled kernel from the repository is like 600 megabytes.
Yeah.
It's just impossible. If you would rely in the debug packages to have it in production, it would be impossible. So thanks to BTF, we're able to use core.
So this is actually just the kernel. This is just the VM Linux. Yeah.
This is just the BTF. So this one in particular for this project, I'm still using ELF. So this file is an ELF file, but it can get even shorter, being a raw BTF file.
Nice. All right. So we got this thing installed. I guess the next thing we should do is go ahead and take a look and see what we see. So if I do just sudo iptables save, you can see all kinds of hijinks, from kubeproxy being configured on this host, right? So this is a Kubernetes cluster, and we're using kubeproxy. I'm sure that many of you already know this, but inside of Kubernetes, kubeproxy is used to route things like services. So when you create a service in front of an application or what have you, and start leveraging that service, then iptables is the implementation by default for how we get traffic from your pod to that service. And we can see the result of that like in here as well. We're also using Cilium, so some of the packet filtering won't actually happen with iptables. Like when you define network policy, because we're using Cilium, network policy won't be implemented here. But in other implementations of a CNI, that is the case. We would see a drop happen, or we would see that here. So I think the piece I'm curious to see. So here are node ports. These might be some interesting targets for us to dig into. We also have, so this is the definition of a service here, right? So this is the iptables definition of a service, where we're saying if the source is 10.01.34.32, DNAT that destination to oh, interesting. Okay. So let's grab this line. I remember actually finding it to be a little easier to read in this way. So here's our service. If it's TCP traffic, we want to DNAT it to the same pod IP and port. Here is effectively the load balancing that happens, if such a thing could be said. Let's do this one as well. So this is the line in IP tables right here that actually handles the load balancing of traffic, right? So when traffic comes to the core DNS service, it's actually being, randomly distributed across different interfaces or different core DNS instances that are hanging off behind that service. And so these are some of the things that I wanted to see if we could see the output of on with this tooling. So let's see what we see. Now this might be interesting because we are using Cilium, and so in some use cases you're going to see that this is actually happening in BPF rather than IP tables. But I think we should still be able to see something and trigger that traffic in here. If I do Conntracker by itself, it's just going to be, it's doing something.
Yeah, it starts and it will dump to the standard out with default options. If you do a -H, it will show you the options you can use. So yeah, the default is like a temporary file. So you would like to have the -T, which is the trace mode, and -E to trace everything, which will add like a full trace to incoming traffic, but it's not mandatory. And -B will enable eBPF, which will have the active K-probes and discover which command generated each flow or received each flow.
All right. So something similar like that.
And then, yeah, it's going to save into tnp conntracker.log.
Jump back into K8 here. So this is a point of capture, and so once I hit Control-C, then it will actually.
Yeah, it's because it's keeping inside the memory a sorted list of all the flows that happened, and so yeah, so it's gonna give you, because it's really hard for you to consume the flows while they're happening. So the idea is to have everything sorted for you. Mm-hmm. And then you can see each chain from. So here is like, for example, what you have there is like you have an ICMP v4, right? And then you have the source and this destination. The tables through this traffic has passed, and also the positions within the tables. So yeah, exactly. So you would have to convert the grep you did before, like, which of the rule from that particular chain, acted.
Is it -LV? Is that right? Yeah.
You can do like a -T table and then -L, capital L, to list. So for example, if you do a -T filter and then -L, you're gonna see the kube services or kube firewall chain, And then you have to look at the third rule there. This was the one that acted in that particular flow. That's the idea. And if you go, so the way it works is like this. With that picture, if you go to the README file in the GitHub, there is a picture of how the flows work in IP tables, and then you know exactly through where the flow passed, you know.
Yeah, you know what? Let's do that. Let's go look at that document. Already I'm seeing value from this because like I could, you know, having run through problems before where I was actually trying to trace a packet through IP tables, it was quite a pain.
It's impossible. So it's very, very difficult for you to know. And so this picture is well known for everybody that plays with IP tables. And the idea here exactly, you have that. So if it's an incoming flow and you know the source and destination, you basically go within this picture like, okay, it passed through pre-routing. And then you go to the pre-routing lines and see raw, mango, and nat, you know. And if it and each of those will have like a position, so you know exactly through which it passed. And then after pre-routing, if it was delivered to local, then you go to the input and you see mango and filter, and then you know the position in mango, the position in filter, and you know if it was. And even if there is in that table there is like 2 or 3 chains where through the flow passes, then you're going to see each chain, you know, like the chain position number 3, and then the other chain position number 2. Or it can say the chain and default policy, which means that it didn't, no rule acted on that flow, you know, just the default policy.
That is awesome. Grant Seltzer says, hello. Yeah, I agree. I mean, and so if we were to like take that in practice again, just a little bit more, and we go back to our IP tables save command. You can see exactly that kind of up here at the top, right? So up here we have, that's our pre-routing that we just saw in the diagram. Mm-hmm. We have output. And then if, and this is all part of the raw table, right? So here's Cilium output raw, Cilium pre-raw. Here's some here are some rules that are going to affect traffic coming in at that early stage. Then we have the Mangle table, the filter table,
and then like for
that table.
Yeah, and then for each of those chains, you have for each of the tables, you have the chains, like you know, cube forward, and then within the cube forward, you have the rules, and then you will know exactly which rule acted. It's like if you have like rule number 7, you know, that was the rule that acted on that particular flow.
Exactly. And when you're reading IP tables, I remember when this finally started making sense to me, it was really kind of a hard one to get my brain around. Was like, if we're looking at this output, right? What this is doing is it's just defining the names of the chains, and then for each rule, like this line, this rule is saying for that chain, here's a comment for that particular rule, and then I want you to jump to another chain.
Oh, like, that's terrible.
Right?
Yeah.
And then like, and there, you know, here's another like, and so as we're reading these IP tables rules, like some of them are like a little bit intuitive, but they're a little harder to understand like what's actually happening, right? So in this case, -A Cilium post NAT. So we know that it's after the NAT that has happened, and then -S means source. So if the source is part of the 10.0.0/24 network, any of the IP addresses in that range, and the destination is a part of that same range, or is not a part of the same range.
It's not part of that range.
Yeah. And is not output Cilium
devices. Yeah, those devices.
Yeah, Cilium devices, which I assume mean any Cilium device because there is no Cilium plus device. So that must be matching a word.
Like a regex or something.
Yeah, exactly. Cilium masquerade non-cluster, and then we push it to the masquerade option.
Yep. I think if you do like an IP tables dash T and the table name, and then dash L, yeah, maybe it's easier to read.
Yeah, maybe. Let's try. So we were looking at Civilian Postnet.
Dash N, so it doesn't solve the, or else you might run into trouble.
N or M? Nancy?
N, dash N.
Yeah.
N for not resolving.
Hold on. One moment.
Sure.
Redirecting my windows all over the place.
Yeah, try doing like a standalone dash N, and it won't solve. Yeah, let's see. Okay, yeah.
Yeah, so these are all of the rules for this chain. And to your point, like if I'm looking up here at this output, it's almost impossible to understand. I mean, at least they're sorted, right? So like we understand that these are the 4 rules that are being presented in this output, right?
Mm-hmm.
But yeah, it is a little easier to
read, the real scenario I had in mind when I did it was like, let's suppose you have a cluster and then you're being blocked by some rule that you don't know about, right? Mm-hmm. And then what you do, you start the Conntracker tool and you execute that flow trying to connect, and then it will get rejected or something. And then you will stop the Conntracker and you go after what happened. And then you will see through which of the chains and tables that flow has passed and which rule has acted. So you know exactly what was the rule that blocked it with that picture that we went through.
We could institute this, right? Because if you create in Kubernetes, if you're using IP tables, if you create a service that has no endpoints, then that traffic is dropped it's dropped out of the bottom of that service. So you'll see the deny, right? So if I were to do, I jump back up here to this upper window and I do kubectl create create deployment nginx and equals nginx table is 380. That creates a deployment of nginx pods, and if we could do kubectl get pods, we can see them running. In just a second. I'm going to show the case where we actually see it working, and then I'm going to scale this deployment to 0, and then we'll see the drop. We should be able to see both cases, right? And so let me do expose deployment. IP and IP address is 10.233.0.1. So from here, to be able to do the listing on a different port. It's listing on the right port. Interesting. Oh, I'm looking at the Kubernetes service. No wonder.
Okay, yeah.
How bad. All right, so if I do curl, that's why I was like, oh, 1, that makes no sense.
It is not, yeah. It wasn't.
My brain, I was like, what? Okay, So now we can see that that connection works, right? We're hitting our Nginx deployment. And if I scale that down, zero. All right, gone. And if I do that same command, connection refused. So in theory, I should be able to see that output in IP tables. So let's do our Conntracker rule.
Yeah, since it's refusing, then you have to have the trace everything, the -e for sure, or else it won't get it.
That's a Conntracker. Nope. Ignorant SSH. C. Temp Conntracker. Does it overwrite when?
Yes, it does. Yeah, it does. It creates a new one.
I was wondering if it would append. That'd be kind of wild.
Yeah, because it's sorted, it would be weird.
Do a search for 10, 233, 44, 242.
So you can see curl there. That was got by BPF.
That's cool.
And then because it did not, so that's the thing, because it did not. Okay, so what you can do is this. So every time there is a flow, I start a trace rule and I keep this trace rule for some seconds, right? What you did was you started Conntracker, you tried once, and then you stopped Conntracker. So the trace did not have enough time to get the second and the third rejection. So maybe if you start Conntracker and try two times, and then I think the trace will happen, or it should.
Let's give it a try. Tracker -B -E -T.
Yeah, because the trace happens, and then now probably the code is getting like the denies, if I remember the code correctly.
Yeah. You have a much better shot at it than I do.
Let's see.
233.
No, it did not. It didn't get the trace, I think. It got the connection attempt because the source port was okay. Oh, so this was the attempt to 240. This is another one, right?
Yep.
This is 150.
This is us communicating. Yeah, this is our source. This is the node where I'm actually sending the request and the destination. It's passing through all of these rules.
Yes.
And then eventually
it will be blocked by some. Or yeah, it's.
And I believe that's probably going to be a drop. Go ahead.
No, I was going there. Yeah, I was going to. Probably that is position number 5. If it's not a drop, then it's a forward to a port that is not accepting anything because there isn't a pod active there. It's just,
-T filter. So,
the dash remove the dash ham. What is it for? I'm not sure. -o. List 9 numbers, yeah. So the 5 is you see, it's the latest where the rule applied, which is like apply for everything.
Yep.
But it passed through the 4 as well, which is the same rule, but for the CT state of new. So every connection that had new flags, so it passed, and then the 5th one was to accept it all. And the first one is Cilian output, is another chain. So it's likely that the flow passed to Cilian output chain and then came back to this one and then went to 4th and 5th, and then it was the last one that applied to that flow.
Yep, that makes sense.
It's not easy to interpret, but it would be even harder if you would try to do this by hand, or because it's almost impossible, because you would have to analyze the NF logs and the trace rules to each of the flows that you have created, and they are dynamic, you know.
Yep, I agree. So this is the rule that is actually giving us an ICMP port unreachable. So this is, I think, where we see the drop. And this rule is part of NAT, I think. Yeah, probably part of NAT. So it'll be.
Let's see.
So this rule right here. I'm looking for 80, and I'm not seeing it. Maybe it isn't part of that.
Yeah, without the. No, it's T. Yeah, the T, Mango, T, NAT. You can remove the kube services, maybe, and then go and do.
There's Core DNS. There's Echo Same Pod. There's. Let's just kick this all into open.
Yeah, it's easier. You can remove RUP.
I'm not seeing it here. What I wonder is if this drop is happening inside of Cilium, and so we're missing it.
Mm-hmm.
If I do, let's break our full screen. Okay. Maybe we could see if that's possible. We could do exit and bubble enable pods. for all this to restart for a minute. What this will do is it turns on the observability that we have for our data path. So if you're using Cilium as a part of the networking data path, then we can actually see what's actually happening there. Yeah, that is really neat, Panda. I agree. Oh, I'm sorry. Let me get rid of that. Thank you, Noel. I didn't mean to block the terminal. Hope I'm saying your name right. Guess we'll see. There we go. Now we do Cilium bubble port forward. Bubble observe. Oh.
Reject? No, I don't know. Dropped.
Completion for the win.
But now the flow is being controlled all by Cilium, right? So even the IP table rules are different right now, right?
Yes.
Okay.
There's like two different layers.
Mm-hmm.
Definitely two different layers where this could be showing up. So this is on KH2 that we're looking. And system. Control C. Before 242. Doesn't look like it's showing up on our side.
Mm-hmm.
This is actually it is being dropped by IP tables. Interesting. If I do,
or maybe it's not being dropped because there isn't a reject or drop. It's just that the port is not opened, and then it's being accepted, but there is a drop rule, so you're not seeing it. If you add a rule to drop it, to force, so let's say you have an open port, but and then it will show you in the rule numbers. Mm-hmm. It will tell exactly what was the IP table rule.
Let's pause back up. So now we're able to see this part of it. So you know what we could do as probably our closing point, because I have about 5 minutes and I have a hard stop. So I want to show the actual success of that packet through the line. So let's jump into the K8s. Then it might be interesting to see like the load balancing piece happen. So I'm going to jump actually back out of here. We'll do kubekittle, scale, deployment, nginx, replicas 5. Okay, and then we can do vagrant SSH 2. We will do Conntracker B minus P. Times.
So this was being load balanced among.
Yeah. So it should have come in on 10.233 and then been load balanced out to the pod IP, one of the pod IPs in the set. So.
Mm-hmm.
It's a little bigger. Make that a little smaller. We should also see the mango for it, I think.
So this is from 244. You have a Cilium Pre, position 4 in Mango.
Yep. Which is probably kicking it up to the Cilium rule set.
I want. Does it load balance coming from the same source multiple times? Oh, it's a probability 0.5. So
it should change.
Yeah.
You should be able to see it. You should see the balance. What I'm curious about, you know what happens? Here's one thing I think we could do. And then these are individual entries for the backend, I think.
Mm-hmm.
Oh wow, there's a probability thing. Even the probability thing is somewhat weird.
Yeah, but those are chains, right? You should be able to see those chains.
So I think yeah, I agree. So I think if I look at the output in your temp file, I'll be able to see a match differently on each, because it's actually balancing over each one. Is that where you were headed?
Yeah.
I think that's right. So if I do IP tables minus M or N G, and that would be part of that. Oh.
So it's the number 2. That's what you will see.
Exactly. And then on the main rule, so I'll see it if that pod is a destination. Otherwise, I'll see it go a different way, which should be catchable by this one. Yes. I should see this output lineup to be different. So if I'm looking for 2CMXP, then I'll be able to see the match differently depending on which path it takes through this mess.
Mm-hmm. Exactly.
CMXP7.
Oh, you can see I'm truncating. So you just found a bug, right? So if the chain name is big, it's truncating a bit.
That's all right. So there's position 4. There's position 2, 4, 1, 3, 4, 2.
Nice.
That's cool. That is really neat. I mean, I really like the action of this. I like that you're able to, follow the application that is actually making the call, and that you have the source and destination, the ephemeral port, and the target is the destination port. And being
The
able to actually
future,
map this stack is really helpful.
yeah, the future of this is going to be, I'm going to remove all the libnetlink part because I'm communicating with kernel and getting all this through netlink, and it's costly, and I don't think it's straightforward because I can do everything with eBPF now. So I'll add the probes to the chains, to the trace in the chains, and then I'll get from the chains themselves for IP tables and for NF tables. And also in the future, maybe to see exactly which eBPF programs are acting, just like Cilium, for example, loading BPF, and then I can trace the programs as well.
Indeed. Well, Rafael, thank you for jumping on with me. I know it's like a last minute ask. I had a great time. I think this is a super helpful program, and I could see like referring some friends who are in the Kubernetes networking space to this project.
I'm happy you like it.
Yeah,
I'm really happy you liked it, and thanks a lot for having me, Duffy.
Yeah, my pleasure. And we'll see you all next week. I think we're gonna have a new host next week. We're gonna have Mr. Walters on doing it, and the week after that, it'll be myself and Justin Garrison talking about EKS Anywhere. So thank you all for tuning in. I hope this was helpful. I find it super fascinating, and I know that Rafael does. Otherwise, why would you write it? Like, anyway.
True.
Thank you very, very much, and we'll see you next time.
Bye-bye.